Lesson 1.4. So this is just basically to help you with, get familiar with and help you do the first two problems that are in the discussion here. We're going to start with a review, some skills, okay, the addition principle and the multiplication principle. From here on out, I'm going to make free use of these, and I'm not even going to mention what they are, because these are really are foundational skills. Okay, so an example of the additional principle. I can take an equation here, y plus 3 equals 5x plus 7. And I can add minus 3 to both sides of the equation. It's obvious, pretty soon obvious why I would add minus 3 to both sides. But y plus 3, which is part of our original expression, and then plus a minus 3 equals 5x plus 7. And then again, we're going to add minus 3 to both sides. Okay, so whatever we do to one side, we have to do to the other. Okay, so y plus 3 minus 3, notice the plus 3 minus 3, those are going to add to sum to 0, equals 5x plus 7 minus 3. Okay, and we're left with y is equal to 5x plus 4. And what we've done is we've just simply placed the equation of a line into a standard format that we call the slope-intercept form. Okay. Here's a second example. We're going to use the multiplication principle here. We're starting with an equation that is 5y equals 10x plus 15. We're going to multiply both sides by 1/5, a fraction, 1 over 5. So 5y times 1/5. Now notice here that I've used the asterisk. Okay, if you haven't done any computer programming, you know that that'll stand in for the multiplication sign. Okay, so 5y times 1/5, and I'm making multiplication explicit here, is equal to 10x, the quantity 10x plus 15, all enclosed in parentheses, times 1/5. Now, when we added, we could just simply add to both sides, but when we multiply, we have to make sure we multiply the entire expression on one side of the equation by whatever factor that we're multiplying by. And then we would distribute that out. This is the distributive property of multiplication. Okay, so 5y times 1/5 would simply be 5 over 5. That's another way of saying 1. 5 over 5 is equal to 1. 5 over 5y equals 10/5. 10 times 1/5 is 10/5. X plus 15/5. If we simplify those fractions, 10/5 becomes 2, and 15/5 becomes 3. Of course, 5/5 is just 1. And the equation of our line in our standard format is y equals 2x plus 3. So let's talk more about this standard format. The equation of line, the slope-intercept form, okay, is y equals mx plus b. We're going to work with that a lot. You can become very familiar with it. The slope, m, can be described as the rise of a run of a line. If we take a look at this graph, we can see that the rise of run, this is generally increasing to more positive values as we run toward more positive values of x, while this one is actually going toward decreasing values. So we would say that this one has a positive slope and this one has a negative slope. Let's see if we can't be a little more formulaic with that. Okay, so more formally, the slope, m, is equal to the rise, okay, in other words, the difference in the y values of 2 points divided by the run, the difference in two x values. This is y2 minus y1, x2 minus x1. Okay, obviously we're going to need some points off of these. If it's very convenient, if you have the graph, is simply to look at where the line crosses the x and y axes and see if it's convenient to pull off some points there. Now notice over here that we have 2 and 1. That's up here. If this was an odd point, maybe you would have come up to some place where the graph actually crosses an interceptor, like this is x equals 1, 2. So that would be another way of doing it. But if we read off the points where this line crosses the axes, the coordinate axes, we'll end up with one point, which is x equals 0 and minus 2, and another point, x equals 1/2 and 0. Let's look at that second one there, because a little interpolation is required. Okay, so 0, 1, 2, 3, 4. Okay, so somewhere between 0 and 1, we're going to get the point where the value where this line crosses the x-axis, and I'm estimating that to be 1/2. Okay, so the slope of this line, okay, again, the difference in the y values over the difference in the x values. Okay, so -2 minus 0 is just -2. 0 minus 1/2 is just -1/2. Okay, so because the numerator and the denominator are both negative, those are going to balance each other out, and we're going to end up with 2 over 1/2 or 4 over 1, and so the slope is equal to 4. The y-intercept, which is the last value that we're looking for here, we have the slope, we need the value of the y-intercept. So we're going to just simply read that off of one of our points here. Okay, so the y-intercept is when x is equal to 0. What is y equal to? And we already have that. We took that point there. This is -2. So the equation of our line is 4x, y equals 4x minus 2. Okay, so what about the second graph? Again, we're going to take the points where the lines crosses the various axes. These are convenient to work with. If you look up here, I have them down here. And point 1 is 0, 2. In other words, when x is equal to 0, y is equal to 2. And P2, which is 2.5 or 2.5, comma 0. In other words, when x is equal to 2.5, y is equal to 0. Notice that we've already got the y-intercept here. Okay, so the slope of this line, we're going to use the same formula here. The change in the y values. Okay, notice here that we're using the second point here, 0, y value from the second point, and then minus the second y value, so this is -2. We're going to use the difference in the x values, the denominator and the numerator, okay, down here, so this is 2.5. And so we have a negative here, but this is a positive value. We're going to end up with a slope that's actually negative, so this is -4/5, and we bring that to some standard form there. And that's exactly what we expect. A downward sloping line is going to have a negative slope. But we can come back, we see that the equation of our line is y equals -4/5 x plus 2. What if we don't have the graph and instead we're given the slope in a single point? So find the slope-intercept formula for for a line with a slope m equal to 2/9, which passes through the point 3, 7. Okay, in other words, when x is equal to 3, y is equal to 7. Okay, so let's come on down here. Given the form of the point slope-intercept, y equals mx plus b, we can fill in the information we have. We have the slope, y is equal to y equals 2/9 x times x plus b. So how do we find the value of the y-intercept? We just read it off the graph before, but let's use the information that we have. Okay, we know that the line passes through the point 3, 7. Well, we have a formula here with y and x. Let's plug those values in. Y equals 2/9 x plus b with these values. Let's just plug them in. Simplify the expression here. 2/9 times 3 is equal to 2/3. We're going to add 2/3, or minus 2/3 to both sides of the equation. So 7 minus 2/3. 2/3 vanishes from the right side of the equation. Okay, and we've already solved here for whatever the y-intercept b is. Okay, so b is equal to 21/3 minus 2/3. In other words, 21/3, 3 times 7 over 3. We're expressing 7 as a fraction over 3, and then we can subtract those fractions. So b is equal to 19/3. And the equation of our line is y equals 2/9 x plus 19/3. Okay. If you have any questions about this, take a look at the timestamp on the video. Please refer to that when you say, hey, you did the step at 8 minutes and 10 seconds. Can you explain that a little further? And I'll do my best, okay? Good luck to you.